Okay, so welcome to 8.07, X and Y intercepts. I'm on period 6 notebook, so period 6, you are on page 50. And we're going to do our first example. So example 1, find the X and Y intercepts of y equals x squared minus 2x minus 15 over x squared minus 9. So I need to find my x and y intercepts. And I know from all the math that I've done and every function that I've ever looked at, I know that an x-intercept always, no matter what, has a y value of 0. And a y-intercept always, no matter what, has an x value of 0. So knowing this piece of information and annotating my question, now I know exactly what I'm going to be looking for. I'm looking for what is x when y is 0 and what is y when x is 0. So looking at the structure of this function, I know it's a rational function, and whenever I'm doing anything with rational functions, I know the first thing I always want to do is I want to simplify it by factoring. And I can look at my numerator and I can see here that I'm going to use reverse FOIL to factor this. And my denominator, I'm going to use difference of perfect squares. So I'm going to factor this real quick. So y equals x minus 5, x plus 3, x minus 3, x plus 3. Now that I factored it, I want to simplify it even more to have the most simplified version of my function. So I am going to find my common factors, which is x plus 3 over x plus 3. So I'm going to cancel those out, and I'm left with y equals x minus 5 over x minus 3. So now I'm going to find my y-intercept and my x-intercept. I'm going to do y-intercept first and x-intercept second, just because finding the y-intercept is a little bit easier. So I'm just going to create a little chart in my notebook to make my work really neat. So I'm going to have my y-intercept over here and my x-intercept over here. So I already identified that my y-intercept is going to have an x value of 0, and my x-intercept is going to have a y value of 0. So I'm going to start with my y-intercept first. So what that means is I'm going to take my most simplified version of my function, which is y equals x minus 5 over x minus 3, and I'm just going to substitute 0 into this function wherever I see an x. So instead of y equals x minus 5, I'm going to do y equals 0 minus 5 over 0 minus 3. And then I'm just going to simplify that. Simplify it again, because I know negative over negative is a positive. And now I'm going to write my y-intercept as a point. 0, 5 over 3. That's my y-intercept. So now for my x-intercept is a little bit trickier. For my x-intercept, I know the y value is going to have to be 0. So I'm going to go back to my simplified version of my function. And where I see y, I'm going to put a 0. So instead of y equals, I'm going to do 0 equals. And what I'm going to do now is for the x-intercept, I'm going to look for the unique value in my numerator. And the unique value is the value that is simply in the numerator, but not in the denominator. So looking at this function, what value is unique to the numerator? And if you said x minus 5, then you are correct. X minus 5 is my unique value in my numerator. So what I'm going to do with this unique value or unique factor, so I'm looking for my unique factor. So this unique factor is simply what I'm going to use in order to solve for my x-intercept. So all I need to do is take my unique factor, x minus 5, and set it equal to 0, and then solve for x. And I get x equals 5. So now when I want to write my x-intercept as a point, it'll be 5, 0, because x is 5 and y is 0. Now here, this example only had one unique value in the numerator, but there might be 2 or 3 or 4 unique values in the numerator, and it's important that all of those unique values get set equal to 0 and solved for x. And then using those values to find our x-intercepts. So let's write down some key understandings just to really stamp this down in our notebook so we have something to refer back to when we're doing some examples. So our key understanding here when we're finding x and y intercepts. So we can find any x and y intercept of a rational function the same way we do for any other x and y intercept. So we can find x and y intercepts of a rational function the same way we do for all functions. And that means that we're just going to, for the y-intercept, set x equal to 0. And for the x-intercept, we're going to set y equal to 0. The only difference is that when we find the x-intercept, so x-intercepts are found by setting the unique factor of the numerator equal to 0. Now I'm going to underline numerator twice. So it's important to note here that I underline unique factor, because unique factor is a key word here in order to determine exactly what we're looking for. We're looking for the unique factor in the denominator, so it's special to the the numerator. So we're finding the unique factor in the numerator, so it's special in the numerator, and setting that value equal to 0. And that is it. So go back and practice your You Do round 1.